Say something.
That's fine. Okay, fine. I think the screen. Okay, so there are a few questions before we go with the live questions because I've been waiting for a couple of minutes, but there are no questions as such. So there is a student called Ninad Patil. Have asked a question. Please explain the following statement in detail. Robustness also accounts for the mean shift. It may be possible that previous distribution be fatter, and by applying robust design concept, the distribution can be thinner, but the mean can shift from the previous one. So yeah, so that is, and then so does robust design include shifting it back again to previous 1 by 1 by some 8s, or keeping it as it is if it is slightly shifted. Okay, the last 3 sentences that I read was directly from what the student has asked. So there are about 3 sentences which was phrased into a question here. The sentences themselves are correct, are partially correct. But however, let me also make sure that I explain a little bit more, or maybe I might re-explain. Okay? So if there are still questions, then we'll address in this live session, or there can also be separate questions, and I will try to attach and give additional material on the course forum directly. So the first question I would extract from the 3 sentences that was posted is mean shift. This is actually an interesting question. Because one needs to appreciate the concept of mean shift to be able to understand 6 sigma, why it is actually only 4.5 sigma. That's where exactly the mean shift concept as a byproduct comes into picture. Even before that, we will just try to understand what a mean shift is. Let's say that you have a washer diameter and you are trying to plot the frequency. As usual, let's say that I'm interested in is about 5 mm. And we ended up getting a large frequency of samples at 5 mm, relatively lesser at a higher dimension, even lesser at a higher dimension. Similarly, on the other side also, plus or minus. What we are trying to tell here is this could be for day 1 or for session 1. Maybe at day 2, I will actually draw it on the same plot so that you can compare. On day 2, probably this pink one. As you can see, the green frequency plot corresponds to day 1 and the pink corresponds to day 2. Though I have engineered this problem here, you can very well see that there is a small shift in the mean. There is a red and there is a black line. The process capability might still remain the same, meaning the variability might still remain the same. However, there could be a small shift in the mean. That is what we are talking about as mean shift. There is about 0.1 in this case, let's say the difference between the red line and the black line on the mean. So the mean between day 1 and the mean between day 2, there is a difference of 0.1 unit. On day 3, it could be between these two guys, or it could be on the left side of these, or it could be right side of this. It does not matter, but there could be a difference. It is very unlikely that you will have the same mean in the every session that you are trying to gather the data. So this is the concept of mean shift. Now what we'll try to do here is, we'll say how this is going to affect your let's say that these are the boundaries of your data that you're trying to capture. So this is for day 1. If I have to draw the corresponding distribution, let's say the distribution was something like this. It's for some data. Let's not worry about what the data is. This is for day 2 now. Then the day 2 is something like this. Then I might have day 3. Could be like this. What I'm trying to tell here is, each of these guys have a different mean. Let's say this is the same process. It could be the washer diameter or some common problem that we are looking at. But there is a difference between the means. On the differentiation, this could have been at 9 o'clock in the morning, this could have been afternoon 12 o'clock, this could have been 5 o'clock in the evening, or this could have been day 1, this could have been day 2, this could have been day 3. It does not matter. It is just that I am doing it in 3 separate sessions, that's all. So there is a, as you can see, to an extent that I've tried to represent here, the variability seems to be the same among the 3 distributions. That defines your process capability, one part of your process capability. But there is a mean shift. Okay, the mean is shifting. In order to account for this shift is what we are using the factor of 1.5. Because if this is 6 sigma, if you're going to define 6 sigma based on one of these guys, let's say this was my original distribution. What we are saying is, in a normalized fashion, if this mu equal to 0 and the sigma equal to 1, 2, and 3. Correct? So this is my upper specification limit, and this will be my lower specification limit. Great. Now what I'm trying to tell you is, this is what is my failure chances. It should be mirrored. It should be uniform on both sides, but in an effort to explain you quickly, this is not mirrored, but it should be the same. Okay? Now what I'm going to do is this is going to change on day 2 or on the session 2, and it might go to the other side on the day 3. As you can see, the areas of failures are different. One sense it was good that I wrote large on this side, on the left side, so that you can see the errors. So I need to account for these errors, but this is the same process trying to manufacture the same product, but at different days. So there is a mean shift. This could be day 1, this could be day 2, day 3, whichever way it is, and there is no guarantee that it will go on one particular direction. So that's why the variability comes into picture. It could be on either side. So there is a mean shift. So in order to account for this mean shift is what we are introducing a 1.5 sigma safety factor, kind of. Hence, instead of using the 6 sigma, what I'm doing is I'm allowing practically. Please understand, this does not mean that if your process is a 6 sigma process, for sure there is a 3.4 parts per million. No, it is not like that. It could be 3.4, the maximum, that's the threshold limit. If it is, then if I am a certifying agent, then I will check for at least less than 3.4 parts per million. So for your 6 sigma, it is actually, if you take the area of probability under 6 sigma, it is much lesser than 3.4 parts per million. For 4.5 sigma, it is 3.4 parts per million. In order to account for this mean shift, we are taking a 1.5 sigma as a safety factor. That's why we are mathematically it is equivalent to 4.5 sigma, but we call the process philosophically as 6 sigma. Please also notice that 6 sigma means it is plus or minus 6 sigma. So as a total, it is about 12 sigma distance. That is what we are talking about. So this is the first question that I wanted to address, which is the mean shift. Yeah, the second question, or rather the second question in the same question was, the second sentence in the same question was, it may be possible that the previous distribution be fatter, and by applying robust design concept, the distribution can be thinner, but the mean can shift from the previous ones. That's a very good question, actually speaking. So yes, so let's just go back to our kiln example. That's where we discuss about this stuff. So we said this is the dimension of your tile. We said just before your initially this is where the problem was.
So 1 cross 1 is what I want my tiles to be, but they are varying. 0.8 cross 1, 1.2 cross 1.2. It could be anything, right? It's just larger than 1 cross 1, that's all. What we suggested, or rather what we discussed, is by applying the robust concept in that particular example, the tile distribution turned out to be something like this. The thinner this distribution is, which means that the closer you are to the target, the more number of times, because this graph does not mean anything other than the number of times. When I drew this larger than this, when I drew this green curve larger than the black curve, the distribution, it means there is a larger probability of samples falling around 1 cross 1. That's all. You just need to think in terms of probability. That's all. Yes, there is a valid question. Great, you did reduce the variability. What happens if this happened? This is a bad thing because there is a mean shift, which you don't want. That is why I'm not sure whether we have discussed this already. Robustness is composed of 2 levels. One is minimize the difference between the process mean and target. And the second point is variability around the mean. I'm sure that this we have discussed in the actual videos though. If I draw these 2 curves and ask you which one is good, the black one or the red one, 100% of the times people who have taken this course will say that this is a better one. But before you tell that, you need to say you need additional information, because I never told you what the target is. If the target was something here, the blue line is what the target is, then the red distribution, though it has a larger variability compared to the black, it's a better distribution because the target is here. You have an excellent process capability. However, the mean of your distribution is far away from what I actually want. So, robust design is a 2-step process. The first thing it says is, we call this guy the M, which is the target, and mu is your process mean. So you want to first minimize the difference between M and mu. That is what is this step. Then around your target, around my target, I want to reduce my standard deviation. So if you bring the same guy here, and let's say that you plotted it like this, then it's excellent. So robustness is a 2-step process where you want to minimize the difference between the process mean and the target, meaning you want to be as close as to the target possible. Then around the mean of the process, you want to reduce your variability. So to answer your question, yes, there could be a mean shift while you are trying to control your process variability, but you don't want to do that. You want to still minimize this difference. That's all. So that needs to be taken care of. So does robust design include shifting it back again to the previous one by some 8s? Yes, you need to make sure that you want to minimize this. You could use some regular process optimization characteristics to make sure that the difference is brought down. That is true. Okay, so now we will go back because there are a couple of questions.
There is a student called Sashank Sasi. You said about Six Sigma manufacturing. Could you please tell in which industry it is used? Actually, it would have been easier for me to answer the question, the complementary of this question. Can I tell in which industry it is not used? Practically used in all the industry today. There are even certificate exams on Six Sigma Black Belt, Six Sigma Green Belt. If you go to companies like, I don't want to name, there are like large corporations which follow this Six Sigma not only for a manufacturing process. Today, if you want to select a particular software, there is a process in which a software is selected in a particular industry. Today, you want to do a fund element analysis. There are at least 100 different softwares which can do fund element analysis today. One particular software is good in thermal analysis, one particular software is good in fluid analysis, one is extremely good in vibration, one is extremely good in multiphysics. But a company cannot buy 10 different softwares for doing more or less the same type of analysis. So what they do is they try to select one out of them, and the process that is used to do this is called Six Sigma. So there is a Six Sigma process to do this. HR people use Six Sigma. So any kind of a process, food wastage is being minimized using Six Sigma process in the food industry, in the catering industry. So practically Six Sigma is used in any kind of process industry. And of late, people have also started talking about how to use Six Sigma in the product industry, meaning in the product design space, not from the manufacturing perspective. Predominantly, currently it is used, total quality management and all these concepts are interrelated. But even at the design level, how do you introduce Six Sigma concepts is being discussed. Okay, but that will be more theoretical in the sense. You might not be able to implement it in a numerical sense, but in a theoretical sense, you will be able to account for the information. So the next question that has come up is, hi sir, this is by a student by name Vijay Karmadi. Hi sir, why is non-linear relationship is useful attenuating sensitivity to noise, whereas a linear relationship is used in shifting the mean on target? Please wanted some clarification for this.
Okay, we'll discuss this. It's a nice question, but I don't like it because I was about to give a homework on that. Okay, now if I explain this, I cannot give the homework, but that's okay. I'm glad that you asked this question because you have the insight to ask this question. That means that you are listening to the courses and videos and you are looking at my responses to the questions. I don't know, maybe Vijay Karmadi was the student who asked the question. Okay, here is the point. Just imagine this is x and this is f, which is a function of. That's all. Okay. Now, overall, what is our idea of robustness? Variation in input should not affect variation in output. Okay, let me erase this. This is not exactly what that is. It actually says irrespective of input variability, output variability should be within prescribed limits. What is our output here? Y equals f of x. So I'm just saying y should be between y1, y2, or Y output can have only a plus or minus 10% of Y output. This is what the variability means. What it is saying is, if, okay, what does variability mean? For this X, for this X here, this is the corresponding Y. What variability says is, you cannot give a point anymore. If you mean this point, it could mean anywhere between here and here. What does it mean? Correspondingly, this is what the variability. If your input is varying, then your output is also varying. How else can I represent this variability? I could probably draw a probability distribution. Or I can just leave it as an interval variable, just like what I just did right now. Okay. But what this definition says is, irrespective of what your variability is, whether you have it like this, or whether you have it like this, or you have it like this, can I make sure that my output variability changes only little? It cannot change as per your input variation. This is what we give. The example that we gave, if you recall, is two-wheeler riders. Once I sell the vehicle to you, I have no control on where you drive, how you drive. So that is the variability. If I'm selling the two-wheeler to 10 different people, obviously or most likely 10 of you will drive it in 10 different conditions. It could be road conditions, it could be the petrol where you pump, the petrol bunk where you pump it, how you drive it, what time of the day you drive it, which city you drive it, all conditions. So these are all the variability in the X. Hence, your output will vary accordingly. What is the output that we are usually interested in? The mileage or the user experience. There will be a variability amongst the 10 people, but the overall goal or the success of that particular bike or the company's success will lie on this variability being around the promise that the company makes. If the company says, I'll give you 45 kilometers per liter, irrespective of how I drive, it should be around that 45 kilometers per liter. This is what it means, okay? So, in the linear function, as you can see, if this is what is your, if the red one is what your distribution is, let's say these are the two limits that I'm looking at, then my variability in the output is also that big. Now, I will just draw another figure to explain what happens in a nonlinear function situation. You have a function like this. Let's take the same case. We'll start with the pink. I need to explain this at 3 different locations so that you appreciate it. So let's say, I might not be able to draw it the same way, but let's say the variability is the same in all the 3 guys. So these are the 2 limits. Now I'm just saying this. Use a different color for the second one so that it's going to overlap. So as you can see, this is at different X, different inputs that I'm taking, but the variability of the X seems to be the same. The means are different. As you can see, this is for the first case, the variability. This is for the second case. And this is for the third case. Don't worry about what the mean of that is. You're only interested in the variability right now. right now. We are interested in the mean, we'll come back to that. We are interested only in the variability. So this is a large variability compared to this guy. And the red one is the smallest variability, as you can see. Whereas in the same space, if I tried using a linear function, you will not get. The variability will be the same. As you can see, from here to here, the variability will be the same. From here to here, the variability will be the same. In the output, I'm saying, for the same input variability, the output variability also will be the same if you have a linear function. If you had a nonlinear function, there are zones that you can explore to identify regions where the output variability is less. That is the idea. Immediately, there could be a question that will spring up and say, oh, if that is the case, let's say that I'm looking at a minimizing my mean kind of a problem, then this is better than this. True, but from a variability perspective, this is a better option. From a variability perspective, this is a better option than this. That's why we use, for instance, to how to formulate this problem. One way to do that would be your SN.
I'm not sure whether we have gone to the SN ratio yet.
I don't think so.
Yeah, and probably if you have not discussed this, the videos are being uploaded tomorrow, day after. SN ratio is something that we will look at. So we are interested both in the mean and the standard deviation. Sometimes it again depends whether you want to maximize your mean or minimize your mean. It does not matter. The formulation still remains the same. And you always wanted to minimize your variability. So we kind of take care of both of them in one sense. But to address the question of attenuating the noise, this is what it means. So the noise means it is the variability. That is what noise means. Attenuating means it is addressing the noise, right? So if you have a nonlinear function, there are scopes in which you can go and improve things. Whereas in a nonlinear function, it is pretty straightforward. In a linear function, it is pretty straightforward. Wherever you go, you cannot do anything about the variability.
I hope that answered your question. Sir, what is meant by Z tilde 1.4? Oh, okay. Yeah, but by answering this question, I am pretty much giving away the answer. Okay. Okay, that's fine. I mean, if that's a question, we'll say. See, okay, I will not exactly give the answer, but I'll tell you what does Z mean. So there is a question by someone asking what does. Okay, I exactly don't know what the problem, what the question here is, because there could be minimal. What is Z? What is tilde? Okay, 1.49, you cannot go wrong. It's just 1.49, right? So tilde means more than or equal to. So around 1.49. It depends whether you are approximating at the third significant digit, nth significant digit. Okay, so that is for this question. That is taken care. The second is what is the Z metric? If you are asking what is the Z score, I guess that's a word that we have used. What is a Z score? See, imagine a case that one of my students or one of you are looking at height of people. And then 5.5 was the average, and then I had some 6.3 maximum, and then I had some 5 max. Okay, so these are all in feet. Then in my lab, there is someone who's trying to look at measuring strengths. And that person also more or less has the same type of distribution. But the only difference being, these are in 2.3 10 power minus 6 microns. Or rather, I will just keep the same thing. Why even change these ones? Okay, the values are the same. 5.5, 6.3, and 5. The only thing is, you should remember that this is multiplied by 10 raised to minus 6. It is in microns. Someone else came and then they said, I am not only interested in the height, I am also interested in the weight. So then we figured out that roughly about 70 kilograms was the mean. And then we have about 120. And then we have about some underweight people at around 55 kgs. Okay. Now, if I want to find the probability content for whatever values it is in each of these cases, I will need different distributions to
Today you might be interested in height, tomorrow you might be interested in micro strains, day after tomorrow you might be interested in the weight. Does it mean that I need to develop different graphs to understand what this is? No, you don't need to. There is a way by which you can normalize. This is, or rather standardize. It's not normalized. So that's why we call it standardized distribution. Any probability distribution, see for instance, this normal distribution, this is called the Gaussian or the normal distribution that we discussed, can be described by two parameters. One is the mean and the other one is its standard deviation. The mean says how tall it is. The standard deviation says how fat it is. This is the simplest way of imagining this type. Okay? The green is taller than the black, which means the mean. Okay, in this case, the mean value could be the same, but how fat it is, the standard deviation captures. Okay, this green is thinner than the black, so the standard deviation is lesser than the other type. That's all. Okay. And from a frequency perspective, the green is bigger than the, that is what the height is, right? Is bigger than the black. The question that I was trying to tell is, you don't need to have three different graphs for this. You can do it by one graph, wherein what you are trying to do is this, by doing some mathematical operations, you are making this mu and sigma to go to 0 and 1, which is called the zero mean and unit sigma. So now I will just have one graph which says the mu is 0 and the sigma is 1. Of course, 1 unit sigma, it can go 2, 3, 6 units, whatever it is, right? And I will give the tables for these guys. I'll give you the table like this. It will go from 0 to 0.1, 0.2, 0.3, 0.10, and in this side also it will go from 1, 2, 3 and all that. So depending on, irrespective of this, what my x-axis are, I can go to this 0, 1, find the corresponding probability content. This going from this to this 0, 1 is what your z score is. This has been discussed in the class. This has been discussed. So please, I might not have used the word score and all that, but we have discussed this. Okay? Going to the standardized form. Just note that, and it should be easy to do that. It's a simple math part. I have another small question. When I was going through Robust Design book, I came across three types of design, like concept design, parameter design, and why three types? Okay, so this is a question from Vijay Karmadi, who says there are three types of designs: the concept design, parameter design, and tolerance design. Why three types? Okay, so first point is I'm glad this question comes up. There are 2 points. Okay, one is someone has gone back to the book. I'm glad that you have. Hopefully, you got the book. So you have gone back to the book. That's an interesting part. The second is you studied the book. Not many of us buy a book and study. So you went through the book and you have questions. So that's a good part. Now coming to the question part. Okay, this is one way of classifying design. For instance, when we teach a design course, what we tell people is there are different types of design. One of this is conceptual design, detailed design, prototype-oriented design. There are different ways in which you can classify these designs. One of the ways that the author from this book, which is part A, has classified is concept design, parametric design, and tolerance design. I'll try to explain what each one of these means is, but this is not an overarching way in which you can classify. There are many other ways in which also you can classify. Concept design is obviously at the concept state. Basically, you say, this is my performance. How can I achieve this performance? If I want to write, I say, when I go and write it on some medium, it should write. It is a board, it's a monitor. Oh, it is an, okay. So there are different things. Okay, what are you going to devise? I'm going to find a pen. Fine. Where will you hold it? I will hold it by my hands. If you're going to hold it by hands, it should take a form of a slender one. So the form follows a function. What is the function? The function will have to be to write. If I have to throw something, then obviously it depends how you want to throw. Is it like a javelin kind of a stuff that you need to throw, or it's a ball like a thing? So if it is a ball kind of thing that I will have to kick around and I'll have to throw, then it should be spherical. If it has to go a very long distance, then it has to be like a javelin. So because that is the form, that is the appropriate form that it can take. So this is the concept design part of it. Okay. So at that point in time, you just say, okay, I'm going to put parts A, B, and C. One is electrical in nature, the other two is mechanical in nature, and when this one works, the other one will come into action, and the third one will come into action, and this is how it works. That's the concept part of it. The parameter design is actually parametric design. So it's also sometimes called as P design, which we also discuss in the lectures. May not be at this level, but what we do is we say key control parameters, key noise parameters. When we discuss these stuff, I would have introduced this is also called the P diagram, which means it's a parameter. So you say these are the inputs. Some inputs come into picture, and then there will be some noise that will come into picture, and then there will be an output that will go. So this is called the parameter. What are the parameters that govern your design? For instance, for an example, I'll tell you that imagine a wind turbine. What are the inputs? The wind turbine's input would be, what is your material of which this is made? What are the types of wind turbine? Whether it is a horizontal axis wind turbine or it is a vertical axis wind turbine. So it depends, right? So there are different types, the material, those things will govern. What are we usually interested? We are interested in the coefficient of performance. But there could also be noise, which means the wind speeds that you cannot control. Sometimes geography could be an input parameter. Time could be an input parameter. So to come up with this kind of a figure is what is called the parametric design. Sometimes what happens is parametric design is also related to a CAD model, let's say. In the CAD model, what happens, you'll have to say what are going to be the dimensions, what will be the arc length, what should be the curvature, what should be the length, what should be the RPM if you're trying to look at a design. So that is generally, it's called the parametric design or the P design. The third one is tolerance design. Obviously, the tolerance design comes from a manufacturing perspective. That's exactly the whole point is about, right? What you see on the computer is not what you get on the field. I might give you some dimensions, but the manufacturer's limitation might not allow them to produce. That's why they ask for tolerances. So you'll have to account for those tolerances to begin with. You cannot have your design that says that it will only accept 5 mm. It has to accept both 4.8 and 5.2 mm. That's the whole point. Okay? So the next question is by average quality loss. Yeah, so this average quality loss is So the next question is, anyway, I was hoping to address the questions, the question that were already posted later after this live session, but this student has come back again. His name is Ninath Patil. He says, he says I have reposted. He or she does not matter, but reposted. So the question is about the average quality loss. LY1 is lost due to product 1. It is not lost due to product 1.
Deviation. So Y1 is a deviation from that.
Okay. So the question is, I guess we say average quality loss is equal to L of Y1 plus L of Y2 plus L of Y3. So the point is, these are instances. Y1, see, this is what we say as Y. And then this is your quality loss. So this is Y1, this is Y2. So there is a similar losses here, L of Y1, L of Y2, like that. So what we are telling is, depending, this is what again the mean shift case, right? So every time it will not do the same kind of difference. For the first person, if you take our two-wheeler example, for the first person it would have worked exactly fine. For the second person, the variation could have been larger. For the third person, the variation could have been smaller. So the loss with respect to each person is different. But the whole point of the probabilistic approach to quantify loss is you're going to do it not in a deterministic sense. You cannot please everyone. You do a product, what you will try to do is I will at least try to satisfy 99% of the people who buy my product. I will at least try to satisfy about 95% of the people that will buy my product. So this is both emotional and meaning psychological, as well as from a function perspective. Okay, but we can talk only about from a, or rather this course is a limitation in the sense that it is only from a performance perspective. So let's say that the deviation from what the promise is, there is y1, y2, and the corresponding losses are L of y1 plus L of y2. Okay, so this is what is the meaning. And I am interested in the average quality loss. Because there are 100 people, then 100 different losses are there. So I will average it out and then I will see what my loss is. Now, what is the question? Is my following interpretation of various terms in the average quality loss? The quality loss, correct. Quality loss for that. Okay, you can say quality for car 1 or car 2. It can also be person 1, person 2. Fine. For car 1, car 2 is also fine. Mu is the average of means of all the cars reading on different days. Okay, sigma is the average of the standard deviation of all the cars reading on different days.
Sigma is not there.
Oh, you mean to say that? Okay, I'm trying to recall because I shouldn't be explaining something because I don't have the slide that I've used. I'm trying to make sure. I guess I would have said that you do a couple of algebraic steps and then you would go to an equation where there is something with a mean component and there is something with a sigma component to it. That's what I would have told you. So, though I might not get the whole thing, but it should be something of this type. It should be mu minus m, where m is the target, and mu should be the process, and sigma should be the sigma around the mu. This is what we should have had. So if you do the algebraic step, you will end up with this. So to be on the safer side, what I'm going to do is I'm going to get back to my slide because I don't have access on this. It is not that I can address the question, but I'll not be able to answer your question. But this is what it is. What I'll do is I'll fill these two steps and probably post a document in announcement that you can go through. So Ninad, this is for you. I'll get back to you with the document on this latest by Tuesday next week, okay? Because we don't work on Saturday, Sunday to upload it. If we can, we'll do it. I'll take the next question, which is by Mr. Krishna Kumar. Sir, you told that using Six Sigma, cost of that product increases, but to sustain in the market, how Six Sigma helps in reducing the price without compromising quality to attract its customers? Okay, good question. See, the point is, also goes back to the one of the already used graphs that I could use is, okay, this is kind of clustered, so I'll redo the graph. Imagine that your your function itself is like this. Usually what we understand is if the quality goes up, the cost also goes up. But that again depends on how your performance relationship, which is what is this graph, with respect to your input variables. When I can only draw a 1D diagram, so I'm drawing it here. When I say X, it means Xi. There could be X1, X2, X3, X4. And we are looking at a projection. It can be any particular variable, right? Now, at this point, let's say this was the cost that corresponds to a particular design. So when I give multiple designs here, you understand that this design, meaning the more it is closer to the coordinate, the better it is, which means it is the least. So from a cost minimization perspective, the more I am towards the cost, the coordinate, it is better for me. But my point is not, or my objective is not only the cost part of it. What I'm saying is I want a better quality also. Quality is measured in the y-axis, let's say. So what you're trying to do here is you're trying to find, not really, quality is not directly on the y-axis, but it's quantified by the variability. So when I say this, there is a variability at each of these guys. This is same stuff, okay? Same stuff that we discussed earlier. So you can see that the variability is here, variability is here, variability is here, and the variability is here. So this is the variability. As you can see, I can't even draw. The variability is very less in this location compared to these. So obviously, from a variability perspective, you will choose these two guys ahead of these two guys. But I also want to minimize the cost part. So naturally, this guy is your winner. Between these two guys who have less variability, this guy is the winner. This is exactly what we are trying to explore is traditionally speaking, if you are going from 3 sigma to a 6 sigma designer, the cost is going to go up. But what you need to do is you need to kind of think whether I will invest in my design by going from 3 sigma to 6 sigma, or I will invest in my warranty claim later. That is a decision between the manufacturer. Because if you have to stay in the market, you have to make sure that your design is good so that you don't get many products for warranty claim. Either you invest a priori or you spend on your repair. What this Sigma concepts tell you is, because you kind of try to take care of this Sigma early enough so that there are not a lot of warranty claims. That's the whole idea. And okay, robust design include both reduction in output variation as well as shifting the mean to the required target. Yes, this was discussed in. This is same person. The same question was. I hope you were there. Otherwise, it is recorded, so you can go back and your question was discussed in detail. So now there are no more questions coming up at this point in time. So what I'll also try to see is there are some questions asked earlier. How to approach the course by someone called Rahul J. How to approach the course and on what aspects do we need to concentrate more from higher studies point of view? Okay, this is a very broad question. I don't even know whether it is in the scope of the course, but I'll try to not to wade off the question. How to approach the course? There is no separate. The funda is the same. You just approach the course just like any other course. You listen to the videos, you understand it. If you have questions, you post, we address it. Try to buy the book, read it, because that gives you a different perspective of the same concept. You can look up the internet. So that is how to approach the course. And this is after all a 8-week course, 20 hours course. So I really cannot modularize this and say, let's focus only on lectures 2, 3, and 4. No, you have to look at all the 20-hour lectures, more from higher studies point of view. We are, from a philosophical sense, we are explaining all from a conceptual perspective. So from a higher studies perspective, irrespective of wherever you are going to do it, I think conceptually you need to understand all of them. So there is anything specific. I cannot tell you, okay, you understand Six Sigma and you will find a position elsewhere. No, that's not going to be. So I hope it at least partially addressed your question. Someone called Raghu Kurela says there is no question. Fine. Vimalesh, generally which will get affected because of quality error? Okay. Pretty much everything. Yeah, the question is not very clear. It says generally which will get affected because of quality error. Yeah, so assuming that you are asking because of error or because of the quality loss, what will I get affected?
pretty much everything. That's what this whole course is about. Okay. So the next question is Rani Kumari. How to crack TCS Ninja? I have no idea, and I'm sure this is absolutely out of scope. One more question like this from the same person, I think the person will be asked to leave the course. You will be blocked. Prashant, how we manage our goal? You have to be more specific on your question, and it should be relevant to the course. I really don't know what your goal is. If you tell us what your goal is, and provided it is related to the scope of the course, we'll be more than happy to address it. So right now, these are the already existing questions that we have. We still have about 5 minutes for 5 o'clock, so I'll still be around. If you have more questions, you can ask. We'll be around for another 5 minutes. I mean, if there are questions, I'll continue to be there. Okay, there is another question. Royal Doe, AK Royal Doe. So, in the few weeks, what can we expect differently, assembly point of view? Okay, see, as you see, I mean, the way that I understand your question, because the question is not phrased properly, but the way that I understand the question, the course is about design for quality, manufacturing and assembly. So right now we are looking at design for quality. Then me or my colleague will explain a little bit on design for manufacturability, where we will discuss on different types of manufacturing stuff like your injection molded situations and sheet metal working, for instance. What are the different things that one need to make sure are take care of while trying to design? That is one thing. Similarly, from an assembly perspective, how do you evaluate two different designs from an assembly perspective? So this is what I think in the introductory video also we have said this. There's another question. What is the pattern of exam for certification? Okay, so is that going to influence you continuing in the course? Doesn't matter. Anyway, to address your question, obviously whatever we have discussed in the class, in the videos, in addition, if you submit the homeworks, you work out and submit the homework probably, it should be easy for you, likely to be easy for you in the final exam. See, you should also probably go and read in the NPTEL website on the exams, because you'll have to pay a registration fee and get yourself, because enrolling in the course and registering for the exams are two different things. Right now, I assume that you are enrolled for the course. That's why you are able to come here and post questions. But registration is different. Registration for the exam is different. You'll have to pay an examination fee and register for the exam. During that time, I'm not very sure, but I assume this is around the same thing. There are about 120 centers across India, so more than that, I guess, and you can select whichever center that is closest to you. And there are exams are likely to be conducted both during in the morning as well as in the afternoon on that particular day. I don't think they offer the exams on different days. It will be on one particular day. It could both be in the morning or in the afternoon. You could take either of them. And when you say pattern of exam, this is an online exam. This particular course will have an online exam. So you'll have to, there will be the center will have computers. It will be networked to the central system. So the questions will be downloaded once you log in. And you should be able to answer on the computer itself. So the questions would obviously take into account the fact that you will be entering through a keyboard. Okay. Yeah. So if you ask the type of question, it could be any kind of question that is related to the course. Very similar to the homework question. See, please be careful with the homework. We might still be giving you only like this 1 point questions, right? But we could have detailed questions later in the later parts of the homeworks and also in the exam. Yeah, see, that's exactly what I was trying to tell you, right? It could be anything. It could be both MCQ, it could be detailed questions, or we would expect you to solve mathematically and tell or give us the steps. It could be anything. Already 5 on. Video. Homework. Yeah, correct. Homework means assignment. Sorry, I use the word what we use at the institute here. Homework means assignment. Correct. You're right. Thank you very much, Ninad. I'm glad that you're enjoying this course, and I'm sure that you'll enjoy it more with my other colleagues when they come and talk about manufacturing, assembly, and sustainability as well. Please stay around on the course. And I remember your question. We are trying to take it up from our external hard drive. We just want to make sure that it does not run into the live session. So what we'll do is, as I suggested, we'll go back and we'll post a file in the announcements so that you can access what the answer is. Okay, so I think since there are no more questions and we are ahead. I mean, the time is also over. It's more than 5 o'clock now. Okay, so there is a very broad assumption here that the answer for question assignment 2s are wrong. To an extent that we have checked, the answers are correct. Even going by the assumption that what you have said is correct, that the assignment 2, the question. I'm sorry, the answers for questions of assignment 2 are wrong. No, we cannot change them, but in case if it is brought to our notice and we agree that the results are wrong, then we will obviously we'll award you this course for that. There's nothing, we'll give points for whoever attended the question. But yeah, so but you need to wait until the deadline, which is the 22nd. So once the deadline is over, I will release what our solution is. Then you can check, and if it's still that, obviously you can contest. And there are chances that we also could make errors, right? So you just let us know and we'll correct it. This is an opportunity for us to go back to our question bank and correct the answers. Fine. Okay, so thanks, Rahul. I hope you continue you continue to enjoy the course. Thank you. All right, so no more questions are coming up. Thank you very much. And yeah, I can't put a smiley. Okay, someone put a smiley. So for that person, here's a smiley. Yeah, I'll see you guys. Thank you very much.